Okay, so this video is of our object, our fan car speeding up in the positive direction.
Okay, so basically the first graph is the graph of the position time graph of what you just saw. And what's happening is it starts at 0 and the numbers slowly increase as time increases, but it increases like exponentially, and it's also speeding up because it's moving away from 0, and it's in the positive direction because it is increasing. And then the equation we wanted to get the equation for this, but because it's a curve, we had to linearize it, which is why in the second graph we graphed position versus time squared.
Because she said it was y versus x squared because it's exponential, so that's why it's position versus time squared.
Yeah. And then what we got from that is that position equals 2.566 inches over second squared times time squared plus 0.4 inches. Now what that means is the plus 0.4 inches is the intercept, the y-intercept, and basically that means at time 0 we started at that position. It's basically 0, so we basically started at 0. And then the other part of the equation is the slope that we used, which is based off the second graph, 2.566 inches per second squared. And basically it works out because the units cancel out with time squared, and it would normally just be like normally we get inches per seconds, but in this case, because we had to linearize it, we got inches per second squared.
Okay, and then after that we found the velocity graph, or the velocity time graph, and since this is exponential, that means the velocities are increasing, and they're all positive because it's moving in the positive direction, and so that's why it makes a line with a constant slope of about 2.5 inches over a second squared, and that's that slope of the velocity graph, that's 2.5 inches over a second squared, is the acceleration of the object. So for our velocity equation to find a velocity, we got velocity equals 2.5 inches over seconds squared times time plus 0.4 inches over seconds. So what that means is that every second, the velocity is increasing by 2.5 inches over seconds. And then at time 0, our initial velocity, which is our vertical intercept, so our initial velocity is 0.4 inches over seconds.
Oh, and basically to answer the question of if this is constant or changing, it's changing because the velocity is increasing.
So now we're going to find the displacement of the graph. So we do that by taking the area under the velocity time graph. So I'm going to go here and click integral, and we get the area equals 19.67 seconds times inches divided by seconds, which is just inches.
Basically.
So that means it had a displacement of around 19.7 inches.
Which means basically that from 0.44, which is where we started, the car traveled for 19.67 inches, about.
So our final position would be 0.44 plus 19.67, which is about 20 inches.
Yeah.